All right, we're back. We're on page 5 of notes 13. We're talking about finding antiderivatives, which mostly come down to doing u-substitutions. We got to get good at u-substitutions. Also, I'm going to start maybe trying to explain to you how I do a lot of these in my head. It's hard to explain how I do them in my head, though, because I'm basically just doing u-substitution. I've just done enough u-substitutions. So here, I'll explain how I would do this one in my head first while showing like some steps. So if I were going to not do the u-subs, if I wasn't going to show the work, which really everyone who does this, they're just doing u-substitution and skipping the work. But I would think that, this should be u, right? So since that should be u, the chain rule should put a 5. There should be a 5 here. So what I'm going to do is I'm going to put in a 5. So in my head, the fun thing is you only have to track like one part of this. You don't have to like do all the work in your head. But I'm going to multiply by 5 over 5. So I'm going to say it's 1/5 the integral of 5x plus 3 to the 10th. Now, doing this means that this is now like almost perfect. And what I'll do is just reverse the power rule, right? So I'm going to say this is now reverse the power rule would give me 1/5 times 1/11. And then 5x plus 3 to the 11th plus c. I need a lot of equal signs. Okay, so this would give me 1 over 55, 1 over 55, 5x plus 3 to the 11th plus c. So I don't know, did that explain anything of what I did? Probably not. So here's what I do in my head. I say there should be a 5 here, so a 1/5 on the outside. Then I reverse the power rule. That gives me a 1 over 11. So that would say 1 over 55, and then it's just gonna be this thing to the 11th. That's how I really do it in my head. Very hard to explain. I wish it was easier so that I could like get more people doing it, but I don't really think there's an easier way to do it. So du is 5 dx. So 1/5 du is dx. So like for comparison's sake, 1/5, 1/5. Like that's where that 1/5 is coming from. It's like I'm really just transforming the whole thing into u's in my head. And the more practice you have, the faster you can do it. Like everyone, within a week, everyone will be able to do this in their head. Like no doubt, no doubt. This is a straightforward problem. So this is going to be 1/5 u to the 10th du. So that's why I'm saying that basically all I need to do at this point, well, once I do the 1/5 thing, I just need to plus 1 times the reciprocal because it essentially is rewritten this way at this point. So now this becomes 1 over 55 u to the 11th, and then it's 1 over 55 5x plus 3 to the 11th plus c. However you want to do it, it doesn't matter. I think it's good if you can do it in your head a little bit, but like you don't need to. Like here, for example, I look at this and I'm like, what? There's nothing obvious. When there's nothing obvious, denominators are usually a really good choice. The derivative of this is going to be e to the x, because the derivative of that's e to the x, and then plus e to the negative x. This is the derivative of the denominator. So this is actually just going to give us the natural log of the absolute value of this. Like that's going to be our answer. If we want to do the work, we say this. So du is e to the x plus e to the negative x dx. So it becomes du over u, which is just going to take us back there. So I'm not going to show that work because that's where it would end up. So this one, I'm going to say this. So I'm looking at this as like 1 over 1 plus 4x quantity squared. 4x quantity squared. Why am I thinking that? I'm thinking this looks like arctan, right? Arctan is 1 over 1 plus x squared. This looks like arctan, except it's not just x squared, it's 4x, the quantity 4x squared. So there should be a 4 in the numerator, a 1/4. I think this is going to give me 1/4 arctan of 4x plus c. Let's do the work though. So I'm going to say that u is equal to 4x. So then 1/4 du is dx. And our integral becomes 1/4 du 1 plus u squared, which is 1/4 arctan of u plus c. So I encourage you to try to get to the point where you can look at this and just work this out. But until then, do the work, right? Like we did the work. The only thing we need to do now is replace u with 4x. That'll take us up here. So we got it. More work, less work, it doesn't really matter. You just kind of go for it. What am I going to make u equal here? This one's not as obvious. I see an exponential. I'm inclined to make it the exponential. I'm actually kind of inclined first to rewrite this as e to the -2 root x dx over root x. All right, I just wanted to do that. And then I'm going to make u equal the exponential. So this one, like, I could probably do in my head, but I'm just going to end up guessing and checking. And so I thought it'd be better to actually do the work. So this is going to be e to the -2 root x times the derivative of -2 root x. -2x to the 1/2. -2 times 1/2 is -1, x to the -1/2, so -1 over root x dx. And then we got to balance a little bit, so I think we can just bring the negative over. Negative du e to the -2 root x dx over root x. Comparing them, I see this and this. There's always dx. Like you can't really lose dx. I mean, you could. Dx is actually really important for other techniques of integration that you're going to learn. So like make sure you're writing it. So perfect. So this is just going to be the integral of negative du, which is -u plus c. And since we said u is this green thing, we're good. So -e to the -2 root x plus c. If I seem to be going really fast, slow down the video and watch them again, pause it, try it on your own. You have a lot of options there. They take practice, like a ton of practice. I think I'm gonna do the rest of the page. Should I? You know, maybe I'll do the next, I don't know. I'm gonna do this one. I'm gonna spend the next 40 seconds making the video longer by deciding if I should do this or not. All right, so 1 minus tan squared is like almost a trig identity, but it's not. 1 plus tan squared is secant squared. I'm gonna make u equal 1 minus tan squared and see what happens. Top of my head, I'm not sure what happens on this one. Du. I need the chain rule. It's gonna be -2 tan of x. Derivative tangent is secant squared of x dx. What's going on here? 1 minus tan squared is negative. What is 1 minus tan squared? I don't think 1 minus tan squared is anything. Secant squared is 1 plus tan squared. -2 tangent times the derivative tangent is secant squared. Does this not work? Am I wrong? What am I doing wrong? What am I doing wrong, everyone? What has happened here? So the problem that I'm facing, it's -2 tangent times the derivative tangent. That is, I'm pretty confident, correct. It doesn't seem to cancel. Have I just am I underthinking it? Am I overthinking it? Should I have cut the video so I could have thought about this ahead of time? What the heck? One radical, what if I made it the radical? That's an idea. I don't think I should do that though. So I don't have the 2 tangent that I need. Am I just doing this wrong? I'm gonna check it on the calculator right now. Let's see what the calculator says. What am I doing wrong? So you just watch me type. Got secant of x squared. Got the square root of 1 minus tangent of x squared, comma x. Oh, people! I just fooled myself. And you know what it is? It was too many in a row that were too simple. So this is what happens, right? So this, I would like to, you know what I'm gonna do? I'm gonna shrink this down and put like a red X through it. This was a false start. So, and maybe most of you, maybe a lot of you, I don't know, are watching and you're like, I know what to do. This is arcsine. And I only know that now because I cheated. Like eventually I would have gotten there because like there aren't a lot of options, but I don't know if it was going to be in a timely fashion. If you let u equal tangent of x, so my tip off should have been, I didn't have this, but the derivative of tangent gave me secant squared, and this is secant squared. Back to the drawing board, right? Think of the ones that you have memorized, which I did not do. Oof, oof, embarrassing. It's not really embarrassing though, because this happens. So this is just, oh man, look at this. Look at that. That's arcsine. All right, well now I'm on the lookout, right? So I am gonna cut this because I don't want this video to be too long, but it was arcsine. All right, I will be back in the next one to hopefully finish this page, but who knows, maybe we'll run into another one. So we'll see, I will see you there.